Mitaka, on the western edge of Tokyo, sometime in 1943. Inside a newly built design and manufacturing facility, engineers from the Nakajima Aircraft Company are drawing an aircraft unlike anything Japan has ever attempted to build. 6 engines. A wingspan wider than 200 feet. A bomb load approaching 20 tons. A range long enough to take off from the Kuril Islands, cross the Pacific, bomb San Francisco or Detroit or New York, and continue on to land in German-occupied France, where it would be refueled and rearmed for the flight home. The man who has pushed this project into existence is Chikuhei Nakajima, the founder of the company whose name is on the drawings, a pioneer of Japanese aviation and a sitting member of the Diet, and the aircraft he wants built has a name that tells you exactly how large he is thinking. Fugaku. Mount Fuji. Nakajima had built his company from almost nothing into the largest aircraft manufacturer in Japan, supplying the fighters and bombers that had carried the Imperial war effort across the Pacific and into China. And by 1943, he was one of the handful of men in the country with the industrial standing to propose something this audacious and be taken seriously. The men in that Mitaka drawing office were not indulging a fantasy for its own sake. They believed, as their army sponsors believed, that an aircraft capable of striking the American mainland directly might change the terms of a war Japan was already struggling to win on its existing perimeter. Here is the story you have probably heard about how that dream ended. Sometime in the last year of the war, the story goes, a crashed American B-29 superfortress was hauled to a Japanese research institute, and the engineers who had spent 2 years drawing Fugaku walked around the wreck of the airplane the Americans had actually built, found technology decades beyond anything in their own reach, and quietly gave up. It is a clean story. It has a single dramatic scene, engineers confronting the proof of their own inadequacy in a hangar. It has been repeated often enough online that it now reads as settled fact. Pause on that story, because it does not survive contact with the calendar. This is not a story about a captured bomber that broke a room full of Japanese engineers. This is a story about an engine that had already broken them, a battle 8,000 kilometers from Tokyo that decided the argument before the argument had properly started, and a cabinet that fell before a single usable piece of B-29 wreckage had reached Japanese hands. Part 1. Fugaku's origins lay in Project Z, a 1942 Imperial Japanese Army specification for an intercontinental bomber, and the specification itself tells you how far Japanese ambition had outrun Japanese industrial reality by that point in the war. Project Z called for 3 variants built on the same enormous airframe: a heavy bomber, a transport capable of carrying 300 troops, and a gunship variant armed with 40 machine guns firing downward through the fuselage at a combined rate of roughly 38,000 rounds a minute, intended to scythe through ground troops on an invasion beach. Nakajima's design, and competing proposals from Kawanishi and Mitsubishi, settled on straight wings, 6 engines turning contra-rotating propellers, and, to save weight on the outbound leg, landing gear that was meant to be jettisoned after takeoff and simply left behind, since a bomber returning empty of its bomb load would supposedly need less of it to land safely. It is worth noting, because this channel has told versions of this story from the other side of the world, that Nazi Germany was chasing an almost identical fantasy at almost exactly the same time: the so-called America Bomber program, aircraft designs meant to reach the continental United States from occupied Europe. Neither Axis power ever flew a prototype of its dream bomber in anger. German industry, working the same problem from Berlin, produced almost exactly the same collection of paper answers: the Junkers Ju-390, the Messerschmitt Me-264, the Heinkel He-277, 6 and 4 engine giants meant to reach New York from occupied France, and every one of them stalled in prototype form or on the drawing board for reasons that echo Fugaku's own: not enough engine, not enough aluminum, not enough time. The country that actually built, flew, and fought a bomber capable of doing this job was the one on the other side of both wars. And it did so while Fugaku was still a set of drawings in Mitaka. Nakajima's company was not a fringe operation reaching beyond its abilities out of vanity. It was already building the Ki-43 Hayabusa fighters flying over Burma, and the Ki-84 Hayate that would become one of the best Japanese fighters of the entire war. Real, mass-produced, combat-proven aircraft. which is exactly why the Army took a request this audacious seriously in the first place. On paper, the numbers Nakajima's team promised for Fugaku were genuinely extraordinary for 1943. A cruising speed above 400 miles an hour, a service ceiling near 50,000 feet, a maximum range beyond 11,000 miles. Those figures existed only on a drafting table in Mitaka. Nothing resembling them was ever tested in the air, because the engine meant to produce them was never finished.
Part 2. The reason Fugaku never left the drawing board was not a captured enemy aircraft. It was an engine. And the engine had already defeated Nakajima's own engineers well before the war's final year. No single Japanese aero engine in 1943 could produce anything close to the power 6 separate power plants would need to lift a bomber weighing over 120 tons fully loaded. Which is exactly why Fugaku needed 6 engines in the first place, rather than 4, the same crude workaround German designers were reaching for on their own America bomber proposals. Because no German engine cleared 1,500 kilowatts either. Nakajima's answer was the Ha-54, sometimes referred to as the Ha-505, an extraordinary and extraordinarily reckless piece of engineering. 36 cylinders arranged in 4 rows around a single crankshaft, rated at 5,000 horsepower, very nearly double what the best conventional Japanese radial engine could produce. On paper, it solved the power problem outright. The HA-54 was, in essence, an attempt to bolt 4 existing 1,800 horsepower engine cores together around a single shared crankshaft, multiplying an already difficult radial design rather than inventing an entirely new architecture. And it is worth saying plainly that Japan was not alone in discovering how badly that particular shortcut could go. American engineers pursuing the same brute force logic built the Lycoming XR-7755, 36 cylinders arranged in a different configuration and rated even higher. And the United States, with vastly more industrial depth to draw on, shelved it too once turbojets made the entire approach obsolete before it ever reached production. The idea of multiplying cylinders your way to 5,000 horsepower was not a uniquely Japanese delusion. It was a genuine dead end that only a handful of countries had the resources to even discover for themselves. In the workshop, it did not survive contact with Japanese wartime manufacturing tolerances, cooling the innermost of 4-cylinder rows reliably, balancing a crankshaft carrying that many throws, machining that many cylinders to a standard that would not shake the engine apart at altitude. All of it exceeded what Japan's engine industry, already stretched by raw material shortages and a shrinking pool of skilled machinists, could actually deliver in wartime quantities. The HA-54 was abandoned as too complex, in the plain language of the official record, and with it went any realistic path to 6 reliable engines for an airframe that needed exactly that to fly the mission it had been designed for. It is worth setting this directly against what the country on the other side of the ocean was doing with the same basic problem. The B-29 that would eventually bear this story's real weight ran on 4 Wright R3350 duplex Cyclone engines, 18 cylinders in 2 rows rather than 36 in 4, an engine that was, by American accounts, badly prone to engine fires early in its service life and required real institutional persistence to make reliable. The difference was not that American engineers were smarter than Japanese engineers. The difference was that the United States had the industrial depth, the precision tooling, the high-octane fuel supply, and the sheer volume of skilled labor to keep pushing a genuinely difficult engine through its teething problems until it worked well enough to fly 2,000 of these bombers into combat. It is worth being honest about how difficult that engine actually was, because the comparison is not simply advanced American engineering against overreaching Japanese engineering. The R3350's crankcase carried enough magnesium that a serious engine fire could burn at a core temperature approaching 5,600 degrees Fahrenheit, hot enough to burn through a wing spar in seconds, and a poor early exhaust layout that routed heat back across the front row of cylinders made those fires more likely than anyone at Wright Aeronautical wanted. During the earliest raids from the Marianas, engine reliability was poor enough that General Curtis LeMay had crews swapping engines after as little as 25 flight hours, barely 2 missions worth of running time. The Americans did not solve this problem elegantly or quickly. They solved it by brute industrial force. Enough spare engines, enough ground crews, enough factories turning out replacement parts to keep flying the bomber into combat while the fixes caught up with the failures.
That option, extravagant, wasteful, and only available to an economy still running at full capacity, was never on the table for Nakajima's engineers in Mitaka. Japan, choosing the same basic path of extreme engine complexity to solve the same basic power problem, ran out of runway to fix its own version long before the airframe around it was ready to fly. Part 3. While Nakajima's engineers were still wrestling with a 36-cylinder engine that did not want to exist, the war was deciding Fugaku's fate somewhere else entirely. American submarines had already sent a large share of Japan's merchant marine to the bottom of the Pacific by this point in the war, and every ship that did not arrive from Borneo or Sumatra or Malaya was aluminum ingot, bauxite ore, or aviation fuel that never reached a Japanese factory floor at all. A shortage no drafting table in Mitaka could design its way around. By the spring of 1944, Japan's aircraft industry was being squeezed from every direction that mattered. Aluminum and high-octane fuel increasingly difficult to move north from the resource areas Japan had seized in 1941 and 1942, as American submarines strangled the shipping lanes carrying them. Skilled machinists steadily conscripted into an army that needed bodies more urgently than the aircraft industry needed hands. Then, between the 15th of June and the 9th of July 1944, American forces took the island of Saipan in the Mariana Islands, a battle that also triggered the Battle of the Philippine Sea, in which American carrier aviation effectively destroyed what remained of Japan's carrier-based air power. Saipan mattered to Tokyo for a reason that had nothing to do with any single aircraft program. Its capture put every major city on the Japanese home islands within range of the B-29, a fact the Japanese High Command understood immediately and viscerally. The fall of Saipan cost Hideki Tojo the support of the emperor, and on the 18th of July 1944, Tojo resigned as prime minister, replaced by the considerably less capable General Kuniaki Koiso. Project Z was cancelled that same month, July 1944, and Fugaku was never built. This channel has not been able to locate a surviving document that draws a straight line between Tojo's fall and the specific cancellation order, and it would rather say so plainly than invent that connection. What the surviving record does show clearly is the wider policy shift the cancellation belonged to. Japan's military leadership had already begun pulling fighter squadrons back from China and the Pacific into the home islands earlier in 1944 in anticipation of exactly this threat. And by late June, weeks before Saipan even fell, the home islands Air Defense Force had been reorganized into 3 full air divisions, carrying some 260 fighters, with several hundred more available in an emergency. An air force fighting for its own survival over its own capital had no material, no engines, and no political appetite left over for a 6-engine dream bomber meant to reach Detroit, whatever the state of its unfinished crankshaft. The aircraft actually being pushed through Japanese factories in the second half of 1944 tell you exactly where the country's remaining engineering effort had gone. The Nakajima Ki-84 Hayate, the Mitsubishi J-2M Raiden, the Kawanishi N-1K Shiden, all of them short-range interceptors designed to climb fast and hit hard over the home islands rather than carry a war to anyone else's mainland. Every one of those programs was competing for the same shrinking pool of aluminum, high-octane fuel, and skilled labor that Fugaku would have needed. And unlike Fugaku, they could actually be built, flown, and thrown into the specific fight Japan was now certain it would have to survive. Fugaku did not die because someone showed Japanese engineers a captured American bomber. It died because Japan no longer had the aluminum, the fuel, the labor, or the government to keep dreaming about one. Part 4. The B-29 itself had already begun bombing the Japanese home islands by the time Project Z was cancelled, though not yet from the Marianas that Saipan would eventually provide. On the night of the 15th to 16th of June, 1944, 75 B-29s flying from forward airfields near Chengdu, China, supplied at enormous cost over the Himalayas under the codename Operation Matterhorn,
struck the Yawata Steelworks in the first raid by American strategic bombers on the Japanese home islands since the Doolittle raid 2 years earlier. The cost of that supply effort is worth pausing on in its own right.
Every gallon of fuel, every bomb, every spare part burned for those Chengdu raids first had to be flown over the Himalayan hump from bases in India, an air bridge so inefficient that American planners routinely reckoned it took several gallons of aviation fuel consumed in the ferrying to deliver 1 usable gallon to a B-29 waiting in China, an extraordinary price paid simply to get the airplane within range of Japan at all, months before Saipan would make the whole arrangement unnecessary. 7 aircraft were lost that night, 5 to accidents and 2 to Japanese air defenses. Among them, B-29 42-6230, nicknamed Limber Dragon, brought down by a night fighter flown by Warrant Officer Sadamitsu Kimura, with the loss of all 12 men aboard, including an American war correspondent riding along for the mission. An aircraft destroyed in the air with its entire crew, breaking apart or burning as it fell, is not an aircraft a research institute can study rivet by rivet. In these earliest months of the campaign, the wreckage Japan actually had to work with was fragmentary at best, a scattering of instruments and structure recovered from crash sites, rather than the intact, carefully preserved airframe the popular version of this story imagines rolling into a hangar for inspection. That kind of more complete access to B-29 technology, where it existed at all, came later, gradually, as the campaign intensified after November 1944, once the Marianas bases Saipan had provided came fully online, and the volume of missions, and inevitably the volume of losses over Japanese soil, began to climb. When the first raid actually flown from those new Marianas bases reached Tokyo on the 24th of November 1944, Japanese air defense was already improvising tactics that owed more to desperation than doctrine. Corporal Yoshiso Mita of the 47th Sentai deliberately rammed his fighter into one of the attacking B-29s that day, destroying both aircraft, one of the first confirmed ramming attacks of the campaign, and a tactic that only makes sense for an air force that has already concluded conventional interception is not going to be enough on its own. Part 5. What Japanese engineers eventually did learn, piece by piece, from wreckage recovered over the following months, only confirmed a gap that had nothing to do with any single dramatic revelation. The B-29 carried a pressurized cabin, allowing its crew to fly and fight in shirt sleeves, at altitudes where a Japanese interceptor pilot needed an oxygen mask and heated flight gear simply to stay conscious, a level of cabin engineering Japan's aviation industry had never fielded at this scale. It carried a General Electric central fire control system that let a single gunner aim multiple remote turrets he was not physically sitting in, an analog computer solving a targeting problem Japanese fire control technology had no equivalent for. Its 4 Wright engines, whatever their early teething troubles, were the product of an industrial base that could machine, test, and mass-produce a genuinely complex power plant faster than it could break. American bombardiers were also flying with a Norden bomb sight nobody in Tokyo had a working equivalent for, a precision optical and mechanical instrument that had taken the United States over a decade of dedicated development to perfect. One more example of a specific, narrow technology that Japan's engineers could recognize as soon as they saw it and still had no realistic path to reproduce at scale in the time remaining to them. The underlying problem ran deeper than any single instrument. Japan's machine tool industry had industrialized roughly a generation later than America's, and a wartime economy cannot manufacture a decade of accumulated precision engineering experience simply because the government has finally decided it needs some. None of this was a secret. Japan discovered in a single afternoon in a hangar. It was the same gap Nakajima's engineers had already met and failed to close with their own 36-cylinder engine, now simply visible from the other side, in the wreckage of the aircraft that had actually made it into the sky, while Fugaku never did. A word on where the popular version of this story actually comes from, because this channel would rather flag that than let it pass unexamined. The image of a single crashed B-29 hauled to a named research institute outside Tokyo in December 1944, walked around by Japanese engineers who then abandoned Fugaku on the spot, circulates widely in short-form retellings online, but this channel has not been able to trace it back to a primary Japanese record, an official history,
or a cited memoir, only to other secondary retellings that do not cite one either. It may describe something that really happened in some form. Partial wreckage was certainly recovered and studied at various points during the campaign, but the specific, tidy, single-scene version of the story appears to be exactly that, a tidy version, and this channel is not going to dress it up as more solidly sourced than it is, simply because it makes for a better cold open. Part 6. The honest version of this story is less satisfying than the one usually told, and this channel would rather tell the honest one. There was no single afternoon when Japanese engineers stood over a captured B-29 and decided, there and then, to give up on their own bomber. The decision had already been made, in a cabinet reshuffled by the loss of Saipan, in a design office in Mitaka, where a 5,000 horsepower engine had already proven impossible to build reliably, and in supply lines already being cut by submarines long before any usable wreckage reached Japanese hands. What examining captured B-29 technology actually gave Japan's engineers, once they finally had the chance to do it properly, was not the reason for the decision. It was the evidence, arriving months late, that the decision had been correct all along, and that the gap it had been made to close was wider than an unfinished crankshaft in Mitaka had ever let them fully admit to themselves. Chikuhei Nakajima lived to see the end of the war he had wanted to help Japan reach America to fight.
He briefly held 2 cabinet posts, Minister of Munitions and Minister of Commerce and Industry, in the government that formed after the surrender, before Allied occupation authorities arrested him along with the rest of that former government, and held him at Sugamo prison to face trial. He was released on parole before the case reached court, and in October 1949, at his home in Mitaka, in the same town where Fugaku had once been drawn out to a wingspan of 213 feet, he died of a cerebral hemorrhage. The design and manufacturing facility that had briefly tried to build the largest bomber ever conceived built nothing of the kind in the end, and the aircraft that actually crossed the Pacific to bomb Japan, again and again, from November 1944 until the war's last week, was the one Nakajima's engineers never managed to catch up to, in an engine shop in Mitaka, in the time they had left to try. His company did not disappear with him. Occupation authorities broke up the Nakajima Aircraft Company in November 1945, splitting it into a dozen smaller firms, run largely by its former executives, one of which built a cheap civilian scooter out of surviving wartime machinery. Its wheel hubs turned on the same jigs that had once cut tail wheels for Nakajima bombers. In 1953, 5 of those successor companies merged into Fuji Heavy Industries, and in 2017, that company renamed itself Subaru. The firm that once drew a bomber meant to burn Detroit now sells cars there. Germany's own America bomber contenders fared no better than Fugaku in the end, canceled, shelved, or reduced to a handful of long-range reconnaissance sorties that never came close to the mainland United States, so that neither Axis power ever managed what this channel's earlier episodes have already shown the Americans and British doing to each other's captured aircraft throughout the same war. An honest, working, mass-produced answer to the machine the other side had actually built. Kawanishi and Mitsubishi, the 2 rival companies that had submitted their own competing Project Z designs, fared no better with their versions, and neither firm's proposal progressed any further than Nakajima's stalled engine. Subscribe if you want the next chapter, because there are more of these. More dream machines that never flew. More honest arithmetic hiding behind a more dramatic myth. More engineers who lost an argument to a shortage of aluminum and fuel long before they ever lost it to a captured enemy wreck. Fugaku means Mount Fuji. It was meant to be the biggest bomber in the world. It never left the ground, and by July 1944, the war had already explained, quietly and in a cabinet office rather than a hangar, exactly why.